All right, so on the last one where I stressed over and over again that momentum doesn't have the same units as force, because it was close, I hope it makes sense that there is some connection between the two. And so as it turns out, remember newtons are kilograms times meters per second squared. You can kind of take that separately as meters per second per second. Sometimes you hear it even pronounced that way. But this gives rise to something called the impulse momentum formula. And in this format is another way of finding force. So sometimes it's rearranged slightly, but this is handy for what we're trying to do here. Your change in momentum over your change in time, so dividing by time on the bottom is where the extra seconds come from, that will give you newtons. So the time is given to us about 1/5 of a second here. So we have the time. What we don't have is the momentum. All right, but we can find that. Our change in momentum, this thing comes to a stop. So we're going to see that this thing comes down to 0 meters per second, or we can see that as zero momentum when it stops. So technically, what we've got is mass times change in velocity, but it's not always necessary to draw all the different change delta symbols. Okay, but if we start working through, we've got our mass, 1597 kilograms. We've got our change in velocity because this thing went to zero. Technically here we're finding um, the magnitude, just the number part. And so we have 65.96 meters per second. And that's going to give us a change in momentum roughly similar to what question one had. So 105,338.12, because why not? And these are kilograms times meters per second, which I keep stressing over and over again. These are not newtons right now, but they will be soon, because when I take over here and I divide by time, that's going to give me the proper combination. All right, so let's look. Our change in momentum, 105,000. That's an 8. Again, these weird units, they get combined from momentum stuff, but the fact here that we're dividing this by seconds again, that's where these get combined, and we end up with force units. So newtons will be on the answer. Then dividing these will give us a very large answer. We get 496,878.